All right, welcome back to Protein Function in Biochemistry. My name is Kevin Tokoph. Make sure to like this video and subscribe to the channel for future videos and notifications. All right, so in the last video, we actually derived this formula up here, which is useful for determining different things in here, like percentage of protein binding sites that are occupied by the ligand, or we can determine ligand concentrations, or if we know the other two, we can determine the dissociation constant mathematically. So we're going to play around with this formula and determine two things in separate videos. So let's look at this first problem. Determine the KD for the protein-ligand interaction if a ligand concentration of 7 millimolar yields 80% of the available protein-ligand binding sites saturated. Then determine the Ka. All right, so we want to determine the KD. And remember we talked about in another video that if you want to find the Ka, you first have to find the KD. And then you can take the reciprocal and get the Ka. All right, so what is it telling us? Ligand concentration is 7 millimolar and 80% of the protein binding sites are occupied. So theta here is going to be equal to 80%, okay, which in the context of this problem, 80% is going to be 0.8. We don't put it in percentage, we put it in decimal form. All right, so here's what we can do. So let's say theta is going to be 0.8. This is going to be equal to the ligand concentration. We just said this was 7 millimolar. This is 7 millimolar divided by 7 millimolar plus the KD, which is what we're trying to determine. So now what I'm going to do is I'm going to take this expression and I'm going to multiply both sides by it to get it out of the denominator. So 7 millimolar plus KD. Take this and multiply by 7 millimolar plus KD. It's a little messy. Hopefully what you'll see is I'll be left with 7 millimolar plus KD times 0.8 is equal to 7 millimolar. All right. So how do we want to go about solving this? Well, let me do this. Let me divide both sides by 0.8. So that cancels that. So what I'm left with is 7 millimolar plus KD is equal to 7 millimolar divided by 0.8. So what I'm going to do is get my calculator out real quick and figure out what that is. All right. So I'm going to take 7 and divide by 0.8. So I get this is equal to 8.75, still in units of millimolar. Now what I'm going to do is subtract 7 millimolar from the other side. And what I'm going to get is that the KD is equal to 8.75 millimolar minus 7 millimolar, and that is ultimately going to be, let's see, 1.75 millimolar. And so that is going to be the KD of this interaction. That's the KD that we have. Now the question asks us to determine the Ka. Well, if we remember the relationship that Ka is equal to the reciprocal of Kd, or 1 over Kd, to find the Ka, we're just going to take 1 divided by 1.75 millimolar, which is what we just found over here. Let's figure out what that is. So 1 divided by 1.75, and I'm getting this as approximately 0.571. And be careful with the units. It's not millimolar, it is millimolar to the negative first power. And that is going to be the association constant for this reaction. Okay? That's the association constant. Now, remember also just a quick review of this, that if we have a high KD, that means weak binding, and if we have a low KD, that means tight binding of the ligand to the protein. All right, so hopefully this made sense. Join us in the next video where we actually are going to do the second problem right here. Thanks for watching.